All right, everybody. So, beginning of Unit 4, we started this in class. So this part right here that's not done now probably got done in class. So we're going to pick up right here at the triangle sum theorem. And it's nice, this is a rule we've seen before. We've talked a little bit about this here, and you all probably knew it from years past. So as you can see, the triangle sum theorem says that the sum of the interior angles of any triangle is 180 degrees. So we know that. We've talked about that a little bit. So just in this particular example, I have three angles. It looks like a scalene triangle. We're not sure, but it looks like it. So we know angle A plus angle B plus angle C must add up to 180 degrees. There's no other way around it. All right, so that's a new formula that we're going to be able to use to solve equations, to set up problems. And it's a really important thing going forward for the year as well. All right, so what I like to think about is this is a budget. We have 180 degrees to work within my budget. So for example 1, I've used up 42 degrees here. We know what that symbol means now. We know that symbol means 90. So there's a couple ways to think about this. What I usually do is I take my budget, my 180 degrees total, and I just subtract what we've used. So we have 180 degrees in our triangle. We've used up 42. We've also used up 90. And we can just do a little bit of quick math in our calculator. And we get an answer of 48 degrees. That's kind of option A. Another way I've seen people do this that works well for them is to add up what we've used up. So we've used up 90 plus 42. So we've used up 132 degrees of our 180 degree budget. So now we take that 132 and we subtract that from 180. And it actually, as it should, gets us to the same answer. So whatever you think works best for you, whatever you want to do it that way. Okay, question number 2. I forgot who it was last class, but we had a discussion about what these two angles, what the name for those angles are. And the name's not really as important as what they do. But you can see again, here's my triangle. I have 1, 2, 3 angles here. And all I know so far is the 68. But hopefully what you noticed, these two angles right here, those are a linear pair. They're adjacent angles off of a straight line, so we know they're supplementary. So I can do 180, minus 102, and that tells me what the measure of angle 2 is. 72 degrees. So now becomes a pretty quick question, just like before. I have my triangle budget, 68 and 72. I've used up that much of it, 68 plus 72. So I've used up, in our calculator, we can figure that as 140. And now to finish up the question, we take our whole 180 degrees, we subtract out what we've used, and we get a total of 40 degrees left over for angle 1. So angle 1, I guess, to finish it up, we should angle 1 equals 40 degrees. Okay, so that's if they give you a nice triangle, they give you some angles. Now what about this? So the variable expressions represent the angle measures of a triangle. Find the measure of each angle and then classify it. So what we have here is a bunch of numbers. What we don't have is a picture. So I'm just going to draw a nice generic looking triangle. I have 3 angles, A, B, and C, so I'm going to mark those in as well. All right, what we know is that angle A can be represented by 3x minus 17. Angle B right here can be represented by x plus 40. Angle C can be represented by 2x minus 5. A little messy there, sorry about that. Well, close enough. 2x minus 5. So at this point, what I want you to try to do is pause and set up an equation using these variables, using these expressions, using the triangle sum theorem. So go ahead and pause and see what you come up with. Okay, so I'm hoping that's what you came up with. We have three angles, and even though they're not nice perfect numbers, we can just use the expressions. So we have 3x minus 17 plus x plus 40 plus 2x minus 5 equals 180. So I'm going to pause again, and I want you to finish this up. So I want you to find x. I want you to find the measure of each angle. Once you find x, I want you to find the measure of each angle. And then I want you to classify your triangle. So go ahead and pause. If you feel like you're stuck, you can unpause it and see what I'm doing. But try it out. Go ahead now. So if you want to check your work up to this point, I just combined like terms. I got all my x's on one side, and I solved for x. So I know x equals 27. So now what we'll do is we'll plug in. So we'll find the measure of angle A, we'll find the measure of angle B, we'll find the measure of angle C, and then we'll classify our triangle. So go ahead and pause again. I'm going to do my work while it's paused, and then check it out after that. Go ahead and do it now. All right, so we're done. I carefully plugged in all my values back into those values there. I plugged in what x equals into my angle measures. And what's kind of nice is that this is a really easy way to check your work. 64 plus 67 plus 49, that does equal 180 if you check it out. So it means we did our math correctly. Now, since all of those angles are less than 90, it makes it acute. And since they're all different, it also means that it is scalene. So there's my final answers. Angle measures, acute, scalene triangle. All right, next page. Isosceles triangles has something called the base angle theorem, which says in a triangle, two angles are congruent if and only if. So there were those magic words we learned last unit. So it means it goes both ways. So two angles are congruent if and only if the sides opposite them are congruent. So what that means, let's say these two sides are congruent. So if you need more time, go ahead and pause, but I want to keep the video going. If those two sides are congruent, it means the angles opposite them are congruent. So you can kind of think about, directly across from those. It would mean that angles B and C are congruent. So I'll mark that in like that. Now what you have to be really careful of, remember the triangles aren't going to always be drawn perfectly up and down like that for you. So if I draw a picture like this, and I tell you that these two sides are congruent, the congruent base angles, again, you think directly across from them. The congruent base angles would be there and there. So it's not always going to be drawn in like a perfect straight up and down isosceles triangle like that. So you have to be really thoughtful about where the congruent sides and the congruent angles are. Okay, but the important thing is that we realize that the sides opposite the congruent angles are congruent. All right, so let's do a couple examples and we'll be done. So, after I said that, if you look at these two pictures, they are drawn kind of that nice way for us. So there's my congruent sides, here and here. That means my congruent angles are there and there. So, 72 right there, that means x is also 72 degrees. That would mean y, think about our triangle budget again. So if that's 72, we know the y angle is our total budget, so 180, minus the two 72-degree base angles. So a quick check in our calculator means angle y must be 36 degrees. Okay, so why don't you pause? I want you to do number 2 on your own. Think carefully and jump back in when you're ready. Okay, pause now. So what we can think about for number 2 is that we've used up 110 degrees right here. So 180 minus 110 is 70. And that's the number of degrees total for A and B. And now since A and B are the same measure, because they're, congruent angles across from those congruent sides, we cut that 70 into 2 equal parts, and we're left with 35 degrees. And there's our final answer. Okay? So that's it for now. We'll probably come in and do number 3 as a bell ringer next class. So if you want to take a peek at it, you certainly can. Otherwise, get onto your online homework check. Make sure you do a good job with those. All right, use your notes. Double check your answers if you don't get them right the first time. And I'll see you in class next time I see you. Goodbye.